All right, so a quick look at the Unit 8 material on solving quadratics. Big things you remember here, the quadratic formula. You go opposite b plus or minus. You do square root b squared minus 4 times a times c over 2a. And the big thing there is make sure we write the equation in standard form. Oh, excuse me, in standard form. And just in case, that means you've written it as y equals ax squared plus bx plus c. Now, one of the uses of the quadratic formula is to find the discriminant, and the discriminant is just what's underneath the radical. No square root, just b squared minus 4ac. And if that is negative, you end up with 0 real and 2 imaginary. So if you think about it for just a minute, right there, if you have a negative number under the square root symbol, you end up, you bring out the I, if you remember, because it's imaginary. So if the discriminant is negative, that tells you have 2 imaginary solutions. And just as a quick reminder too from yesterday, that probably means that your graph does something, you have a parabola, maybe something like this, where it just doesn't touch the x-axis. If the discriminant is positive, you have 2 real and 0 imaginary solutions. So an example there, we don't know which direction it opens, but you would know that that parabola touches the x-axis twice. Whether it opens up or down, we aren't sure based on the discriminant, but it could be, what we do know is that it touches the x-axis twice. And then finally, if the discriminant equals 0, excuse me, there are 1 real and no imaginary solution. So again, what that looks like, if you remember, that just means that it touches once. So using the quadratic formula, solve this equation. So we've already got it in standard form. So a is 2, b equals negative 3, and c equals 6. So let's plug it into the formula. So opposite b, so x equals opposite b plus or minus b squared, so negative 3 squared minus 4 times 2 times 6 over 2 times a. So 3 plus or minus, it'll be 9. 4 times 2 is 8. 6 is negative 48, and then we're over 4. And then very quickly, 9 minus 48, so we'll end up with 3 plus or minus the square root of negative 39 over 4. And the one thing that we can't break down 39 beyond 3 and 13. So we have 3 plus or minus, but I can pull that I out. End up with 3 plus or minus I root 39 over 4. So using the discriminant, excuse me, how many real and imaginary solutions? So here, already in standard form, a equals 1, b equals 3, c equals negative 28. So b squared minus 4ac. So the discriminant, 3 squared minus 4 times 1 times negative 28. And that's going to be equal to positive 121. So there's the discriminant, 121, which tells us we have 2 real solutions. 28. Let's move that 5 over very quickly. So we have 7x squared minus 5x plus 8. Oh, excuse me, plus 3 equals 0. So a is 7, b is negative 5, c is 3. So the discriminant, b squared, negative 5 squared minus 4 times 7 times 3. And that's going to equal negative 59. And a negative discriminant tells us we have 2 imaginary solutions. So one of the quick ways that you can kind of check this, if you'll take your equation now that we're in standard form and put that into Desmos or your graphing calculator, so y equals 7x squared, 7x squared, I have to go back and remember what it was, minus 5x plus 3, 5x plus 3, what we can see is that's a parabola that doesn't touch the x-axis. And what we remember from yesterday, that's 2 imaginary solutions. And sure enough, the way that we just did this problem, we got a negative discriminant, which told us 2 imaginary solutions. All right. So there's one way to kind of check your answers as you go. Here, already in standard form, so a is 1, b is 4, c is negative 4, so the discriminant, b squared, 4 squared minus 4 times 1 times negative 4 is going to be 16 plus 16, which is 32. So that's positive, which means we have two real solutions. And then here, let's add 7 to both sides. Oh, excuse me. So 3x squared plus 5x plus 9 equals 0. So a equals 3, b equals 5, c equals 9. So the discriminant, 5 squared minus 4 times 3 times 9, which is negative 83, which tells me I have two imaginary solutions. So based on the graph, determine the sign of the discriminant. So here's another way we can kind of approach this. Here there's two real solutions, which tells us that the discriminant is positive. Here there's one real solution, which tells me the discriminant equals 0. And here there are two imaginary solutions, 0 real, which tells me that the discriminant is negative. Now, if we're going to start solving these things, a couple quick things to remember. When taking the square root, make sure you isolate the squared term. And then make sure you don't forget the plus or minus. So let's go through this one real quick. So divide both sides by negative 4. So we've isolated. We got x squared equals negative 25. And now when I take the square root of both sides, with x on this side, so plus or minus square root of 25. Well, we know the square root of 25 is 5, and because there's a negative underneath there, we also have the I. Here, divide both sides by 7. So x squared equals 8. So we take the square root of both sides. So with x, that's 8, we can break it down. 4 times 2, 2 times 2, so we can pull out, do the plus or minus, 2 root 2. The next step is to solve by factoring. So make sure we set this thing equal to 0. You want to go ahead and factor, and then you set each factor equal to 0 and solve. So the first one here, if we break this down, we want factors of negative 28 that add up to be positive 3. And I believe that'd be 7 and negative 4. So we have x plus 7 and x minus 4. And so step 2 says set each of those equal to 0. And then solve. So subtract 7 from both sides on the first one. So x equals negative 7. Here we'd add 4 to both sides to this side. So x equals 4. So my two solutions, negative 7, positive 4. Desmos would be a great thing to use to kind of check your answer here. So we have x squared plus 3x minus 28. So x squared plus, excuse me, I got to go back and make sure, plus 3x minus 28. So plus 3x minus 28. Sure enough, if I click there, there's negative 7, positive 4, which is exactly what I got by solving. Right, and here's a good reminder. Remember when there's a leading coefficient, we do a times c, so we have negative 30 that add up to be negative 13. I think negative 15 and positive 2 will do the trick here. So x minus 15, x plus 2. Don't forget to come back and divide through by 3. Divide by 3, divide by 3. Simplify where we can, so we end up with x minus 5. And can't simplify 2/3, so we end up with 3x plus 2. So we go x minus 5 equals 0. So let's go ahead and solve that one. Add 5 to both sides, so x equals 5. Or 3x plus 2 equals 0. Subtract 2. So 3x equals negative 2. Divide both sides by 3. So x equals negative 2/3. And x equals 5. And then finally, quadratic formula. Again, make sure we set this thing equal to 0. And then label a, b, and c before you plug them into the formula. So here we go. A equals 1. B equals 2. C equals negative 5. So x equals opposite b, negative 2, plus or minus b squared minus 4 times a times c over 2a. So now it's just a matter of step by step. Let's make sure that we work this thing out. So 2 squared is 4. 4 times 1 is 20. That with plus 20 because 4 times 1 times negative 5 is negative 20. That over 2. So we end up with negative 2 plus or minus root 24 over 2. And let's break 24 down. So we have 4 times 6. So 2 times 2. 2 times 3. So I can pull a 2 out. So negative 2 plus or minus 2 root 6 over 2. And here's one of those guys. Remember the heart rule. And all three of those, we can pull a 2 from all of them, which would leave us with negative 1 plus or minus square root of 6 over 1, which is really just negative 1 plus or minus root 6. All right, and then finally number 37, let me give myself a little bit of space. A equals 2, B equals 3, C equals negative 6. Actually, both these were pretty nice in the sense that we didn't have to do any work before we start the quadratic formula. So opposite B will be negative 3, and then b squared minus 4 times 2 times negative 6 over 2a. So here we go, negative 3 plus or minus. So we end up with 9. 4 times 2 is 8 times negative 6 is negative 48, so that turns into plus 48 over 4. Negative 3 plus or minus, maybe the square root of 57 over 4. I know that 57 will break down to 3 and 19, but it doesn't break down any further. There's nothing in the heart, so your final solution for number 37, negative 3 plus or minus square root of 57 divided by 4.